Hello, I am Micah Wolf with FOAB and 9185 Robotics. This is part 4 of our video series using Pros 4.1 and Easy Template 3.1 jumpstart your programming journey through VEX Robotics. In this fourth video, I will be going over how to implement lift PID control based on the Easy Template tutorial available on their GitHub website. Shown here, where you can find that is right on their homepage. There's a PID tutorial here. I'm basically just going to be walking through the steps they have on the website here and explaining what I can as we go through. First thing is we're going to set up user control. We're then going to look at what it would take to set it up in autonomous. If you're going through the website while we're going over the video, I am going to skip over example 2 and go straight to utilizing tasks. And tasks are a way for a function to run at the same time as our other functions, essentially allowing us to control the rest of the robot while the lift is activating and moving around in the background, allowing us to multitask. That being said, we're going to go ahead and get started here. As you can see, we're going to get started in the globals file. I've already created a motor. The only thing that changed when creating this motor is I included pros motor units for counts. You can use degrees, rotations. I personally prefer counts because they can seem to be a little bit more accurate. The other thing that's going to change from the tutorial available on their website is I'm only going to use one motor. As basing it off of recent games, that's more likely the scenario you're going to run into when programming your robot, as more and more teams are switching to 6-motor drives. So now that we've created that motor, we're going to go ahead and go into helpers.hpp, and we're going to create a few functions here. The first thing I'm going to do is I'm going to just comment a section here for lift. We're going to create a set lift function, and we're going to pass it, of course, just like the set intake, lift power as our integer. We're also going to create a PID item or object. We're going to utilize the Easy Template PID. So the way you do that is we're creating an Easy PID object, and we're going to just call this lift PID, just like that. The next thing we're going to need is we're going to need a function to wait on the lift to go up. So this is going to be lift wait. We're going to need a task function to run the lift in the background. So this is going to be lift task. And then that is all. That is all of the functions we need to run this lift, both in autonomous and driver control. So now what does this look like when we're actually creating these functions? Let's go ahead and copy this over to helpers.cpp, just like that. And we're going to start by, we're going to leave the 2 here. These are for Auton, these 2 right here. We're going to start with the 2 on the top. So the first one, of course, is going to be just like our set intake. We're going to do lift im dot move, and we're going to pass it lift power. Again, this is done for in the future if we need to add a motor or change it to 2 motors or anything. It's a lot easier to just go in and change this one function instead of having to go through and change it in every instance. So that's why it may seem redundant to only do with 1 motor, but it can really help future-proof your programming. The next thing we're going to do is we are going to add in the additional items or numbers for our lift PID. This is going to be your P value, I value, D value moving down. So we're just going to put zeros in for all these. There's also an initial I value for it to start moving. And then finally, we're going to just call it its name. So it's for the lift. And then finally, we need to get rid of extern there. Okay. Just like that, we have done everything we need to in helpers to be able to set this up for driver control. So that's what we're going to do next. So let's go ahead and open up our main.c file. The first thing we're going to need to do is actually these two lines of code right here. So this is going to be liftm.tear position. What this does is it resets the motor to 0 when the robot turns on and initializes. That's just resetting everything back to 0, basically making it ready to go moving forward. The next thing that's set up in the initialize section of the main file is the exit conditions. And now these exit conditions are going to be different for every robot. These are just what is used in the tutorial and is a good starting place, but you're really going to want to go through, zero all these out, and then adjust your exit conditions for your robot and your use cases. And again, that is talked about on the Easy Template website in their tutorial on tuning constants. It's discussed a little bit there. Okay, so the next thing we're going to need to do here is, okay, now that we have that set up and initialized, I actually forgot. We are going to need to set up the other two functions since we're using it as a task. So first we're going to set up the lift weight. So what that's going to look like here is we're going to put in a while loop. In that while loop, we are going to put a delay using the utility from Easy Template. I'll show you that here. Just like that. Now, what are we going to put in the condition of the while loop? That's actually going to be the lift PID exit condition. So what that's going to look like is lift PID dot exit condition, like that. And then we're going to need to pull that exit condition or track it somehow. So we're going to do the motor. So that's going to be lift M, comma, true. Equals easy running. So that's our wait command to wait for the lift to finish its motion. The next is going to be the task function. So the first thing we're going to need to do is put in a delay for the initialize to finish running, allow everything to get reset and ready to go at the beginning when this task starts running. So we're going to put in 2000, that's in milliseconds, so that's actually 2 seconds. The initialize normally takes about 3 seconds before you will feel the buzz on your controller. Like that. And then we're going to put in another while loop. And this condition is true because we want this to run constantly, just like OP control. This is expected to continue running until the program ends. And we're going to use our set lift function here. So set lift. Now this is, instead of giving it a number or passing it a straight integer, we're actually going to use the compute function for our lift PID. So that's lift PID dot compute. And what this does is actually does the math for PID utilizing the PID values you set in your helper file just up here. So using your PID values to help calculate how much power the motor needs at any given moment. And to be able to do that, it has to be able to read the sensor. So that's what we put in the condition for this compute. And this is just going to be, in this case, the lift motor. dot get position. And just like that. Now you can also do this with a rotation sensor or a potentiometer if that's in your use case. But for the most part, unless you need it super accurate, the internal sensors on the motor itself should do a good enough job to be able to do this. The last thing, if we're going to want to just download this and see if it runs, is the P value here needs to be above 0 or it will get no power. We're just going to set that to half right now. You may need to adjust it when you're tuning your PID, which that tutorial can be found on the Easy Template website and maybe a video I put out later. But for the time being, I recommend using the tutorial on the Easy Template website. Okay, so the last thing we need to do is we need to actually put the run the task in the main file. So I'm going to take this, go to the main file, and I'm just going to throw this up here above initialize so it can starts running like that. I named it differently. So pros task, it creates a task. We're running our task function. So just like that, I created a pros task. Its name is lift task, and it's running the function lift task. Notice the difference in upper and lower case. It's very important to make sure that those are correct across your multiple files and how you have it set up. Now we're ready to use this in OP control. So the way we're going to do this is actually pretty easy. Is we are going to use an if-else structure here, just like we have in the past videos for pneumatics and intake. Again, you can add more else-ifs if you need multiple buttons for things. This is just an example. So what you would do is you would do lift PID, and we're going to set a target. So that's how PID works, is it works off of, has it reached the target yet? So we're going to do target set, and let's say we needed to go to 500 counts. We don't know. You don't know exactly how far this needs to go until you actually read where your lift needs to be based on the encoder counts. And I'll actually show you in a minute a little trick that can help find these values for how much your lift motor needs to spin. So our other button here is going to be lift PID target set, just like that, and that's going to put it back, bring your lift back down. Now for the little trick that I use to help find my target values when I'm tuning my robot, along with like tuning the PID values, and I need to find how much or the target counts for the motor to hit. So what that's going to look like here, I'm going to create a local integer here, count controller. Count controller. And this, I'm going to print the value of the sensor directly to the controller so I can help just physically move the lift exactly to where I want it to be. It'll print the value straight to the controller, and then I can come in and edit this value. So how I'm going to do that is we are going to use an if command. So if not count, if count controller divisible by 25, it's not divisible by 25. If you want to know how this works exactly, I recommend looking up like basic math functions in C++. And that'll go over what the percent sign does, double equal, stuff like that. I highly recommend getting that base understanding of what those functions and symbols do. The explanation point is not, I already covered that in another video. But essentially, I'm just dividing this by 25 and seeing if there is anything left over. When that value, when it passes as true, what we're going to do is we're going to use master, which is the controller. So master.print. And it is line 0, column 0. Well, I'm not going to put any text in here. I just want the number. So %LF. And then the last thing is we need to give it where it's pulling the information from. And that's going to be lift m.get position. So, and then the other thing is we need to increase the count controller to increase that count so it can continue checking and updating our value. So what that's going to look like is just count controller ++ to the line of code. So what this is doing is it's adding, every time it cycles through the while loop, it is adding 1 to that counter. When it is not divisible by 25, it prints to the screen using the lift.m to get position. If you have multiple motors, you can just change which motor you put here. If you don't want it printing to the screen after you determine the value that you need, you can just comment out this middle line and leave this in your code. It's not going to hurt anything. If the task itself is holding the lift down and you're unable to move it freely, you can come up here and switch off the task just by removing it. Just like that. But that's how you set it up for driver control and find those values of what those targets need to be. Now, how does it work in autonomous? That's the last part of this, and I'm just going to show this in helpers here since we haven't done the autonomous video, which will be next. So how this would work is you would do lift because it's in a task and it'll constantly run, and you can do other things while this is running. You don't have to do an autonomous function. All you have to do is you come in here and you do lift PID dot target set. Let's say it's the 500 again. Again, this is going to show a red line because it's not in a function. But we're going to set the target to PID, and then we're just going to run our lift wait function. That's it. And then if we want to bring it back down to 0, we put in a delay, or we move the robot over, or we activate our intake, and then we set the target to 0 and wait for it to finish again. So that's how you do it in Auton. It's pretty straightforward. Again, the tutorial I followed is on the Easy Template website. I just hoped this video could help answer some questions on why certain things are done a certain way and give some tips on how to do that. In the next video, I'll be going over how I set up my Autons file to help with PID tuning, and how to add Autons moving forward as you progress through the season.